Hello, this is Mr. Ensler, and I'm going to be going through the chapter 11.5 through 11.8 review. And this chapter consisted of 4 lessons. The first one, 11.5, was all about the distance formula. Now, the distance formula is given right here, and what you do is you basically subtract your two x values, and you subtract your two y values, you square both of them, you add them, and then finally you take the square root. So if it helps, what you might want to do when you get your 2 points, you may want to identify the x values and the y values. So in the first point we have an x and a y, in the second point we have an x and a y. It really doesn't matter which one you call x2 and x1 or y2 and y1, as long as these are both x's, as long as these are both y's, you can actually do it in any order. I usually do it in the order that's most convenient. So I'm going to make the radical. In the first parentheses, I'm going to do x minus x. So I could just go in order, 4 minus negative 8. And then in the second parentheses, maybe I'll go in the same order, negative 7 minus negative 2. Okay, so now you actually need to do that operation. What is 4 minus negative 8? Well, that's really going to be plus, so you can just enter it into your calculator and you get 12. But then you have to square that. That's built into the formula. So 12 squared is 144. All right, over here, negative 7 minus negative 2. You could just enter that into the calculator or realize that minus negative means plus, so it's really negative 7 plus 2. That's negative 5. And then you square that. Now really you're squaring the negative part also, so it should become positive 25. We still have this plus sign in between there, and this is all still under the radical. Sometimes I don't write the radical through every step of work here, but you need to know that all of these numbers are still under the radical. Alright, if you add those together you get 169. And now you just need to simplify this radical. Either it comes out evenly, or it doesn't, and you'll have to round as well as simplify. This one actually comes out evenly. If you type in square root 169 to your calculator, it just equals 13. So the distance between 4, negative 7, and negative 8, negative 2 is 13 exactly. Number 2. Kind of set this one up the same way. X minus x goes in the first parenthesis, so I'm going to do 3 minus negative 1. And in the second parentheses, y minus y. So I'm going to do 10 minus 5. Alright, so in that first parentheses, 3 minus negative 1, that's actually plus, so that would be 4 squared, which is 16. In the second one, 10 minus 5 is 5, and if you square that, you get 25. Add those together, you get 41. So remember, this is all underneath the radical, square root 41. And so, let's see here, 41, what does that equal if you do the square root? I'm just going to type that into my calculator. It does not come out evenly. If I round to one decimal place, it's 6.4. So then the question is, can I simplify radical 41? Like, can I split it up? So what does 41 divide by? Well, it doesn't divide by 2. It doesn't divide by 3. It actually turns out that 41 doesn't divide by anything except 1 and itself. So the exact answer is radical 41, and the rounded answer is 6.4. And as the directions say, find the exact distance, and if you need to round, give a rounded answer as well if necessary. Alright, number 3. So set up our radical, x minus x. So I'm going to do 7 minus 5, y minus y. Now, you can do 1 minus 9, that's fine, but you can also do 9 minus 1. That might be a little bit easier because your answer will end up positive. So 7 minus 5 is 2, square that you get 4. 9 minus 1 is 8, square that you get 64. Those get added together because the plus sign in the middle. So we have square root 68. Alright, does that come out evenly? What does square root 68 equal on my calculator? It says it doesn't come out evenly. It's approximately 8.2 if we round to one decimal place. But I bet 68 can split up. What can you divide 68 by? Well, 2 and 34. And 34 can divide into 2 and 17. And 17 can't divide anymore. And remember, our rule, if you're going to use this way of simplifying, is that any pairs of numbers form a number that makes it outside the radical. So this is actually going to equal 2 radical 17. So we want both. We want the exact answer, definitely, and then because it doesn't work out exactly as an integer, we will also round, and that's what that 8.2 is. All right, last one of these. So we'll do x minus x. I'm going to do 3 minus negative 4, and then plus parentheses y minus y. I'll just keep it in order, 2 minus 3. So let's see here, 3 minus negative 4, that's really going to be plus, so 7 squared, which is 49. Over here, 2 minus 3 is negative 1 squared. And remember, when you square it, it should turn out positive, so this should just be 1. Really, you're squaring the negative part also. So then those get added, and you have square root of 50. Does square root 50 come out evenly? No, it doesn't. It equals approximately 7.1. But I always just type it in right away because if it doesn't come out evenly, you're going to need the approximate answer anyway. So you're not really wasting anything by doing that. And now let's go ahead and simplify this. I know this can split into 5 and 10, for instance, and 10 can split into 2 and 5. So it looks like we have a pair of 5s and a 2 left over. So there is our exact and approximate answer. And that also works. If you enter in 5 times radical 2 on your calculator, you enter this in, it will equal 7.1 approximately. All right, so that is the basic distance formula. Now, we also studied some what I like to call backwards problems. Notice what the directions say here. For 5 and 6, find the possible values of a given the distance. Show work. So we are being given the distance. You know, the last 4 problems, we figured out what the distance was. Now, in number 5, we're just being told it equals 10. So when you do the big radical, we're being told right away that's going to equal exactly 10. So what you're going to do is you're still going to set up the x minus x and the y minus y and the plus sign and the squared. It's just that one part of that is going to be unknown. So, for instance, when I do the y's, I have negative 1 and 7. I'm going to put the 7 first. I think that would be easier to say 7 minus negative 1. And so that's really 7 plus 1, which is 8. And you square 8 and you get 64. For the other, it's going to be easier if you put the a first. That way our variable is positive. It's just easier when your variable, your letter, is positive. So I'm going to put a minus 3. So you have to square a minus 3. Now make sure you do not do this. That is not how you square a minus 3. Don't do that. All right. To square a binomial in parentheses like that, it's like you're going to write it out twice. It's like it means a minus 3 times a minus 3. And so to actually multiply a minus 3 times a minus 3, you can either FOIL or use the box method. I know a lot of you like using the box method, so I'll do that. It's really the same thing, the box method and FOIL. So a times a is a squared. A times negative 3 is negative 3a. A times negative 3 again is also negative 3a. And lastly, negative 3 times negative 3 is positive 9. Now those are like terms there, so they can be combined. So we're going to have a squared minus 6a plus 9. And then that will add to the 64. And all of this is still under the radical, at least this whole left side, and it equals 10. So I zoom out here, you can see it still all equals 10. So let's combine those like terms, a squared minus 6a, and then do you see how 9 and 64 are alike? So if you add 9 and 64, you get 73, and then that equals 10. Okay, so now this is like a problem that we studied last chapter. Anytime you have things inside a radical that you need to get to, we need to figure out what a is. what you're going to do is square both sides. I like to rewrite it so I can really show what I'm doing. And I'm going to square that side, and then I'm also going to square the other side. And what that will do is that will just get rid of the radical. So now it'll just say a squared minus 6a plus 73. On the right, you actually have to square 10, so that's 100. Now, we've got to solve this. I'm going to move the 100 over by subtracting it, because you can see this is a trinomial where we have three different types of terms, an a squared, an a, and then just a regular constant term. So that's actually going to be minus 27 equals 0. And so the way that we're going to solve this is by factoring. We know it's going to be a, and this is where you can ask yourself, what two numbers multiply to make negative 27, but add to make negative 6? So there aren't that many numbers that multiply to make negative 27. The only ones I can think of are 9 and 3. And I know one of them has to be negative, one of them has to be positive. And the right way is minus 9 and plus 3. That way if you add them, you get negative 6. Now you could have them in the opposite order, but the 9 has to be negative, the 3 has to be positive. So then technically what we do is we set each of these equal to 0. Often we take a shortcut, and because we realize that if we set it equal to 0, the way to solve that minus 9 would be to add 9. And so we just know the answer is going to be 9. And over here, we have to subtract 3 and subtract 3. So a lot of people, what they do is after they figure out the factoring step, they go right from that step to the answer. And that is fine. We've done this often enough that we know that those are the answers. So there's actually two answers to this. A could equal 9, or A could equal negative 3. That's a negative sign there. All right, let's do another one. If you were confused by that first one, I think this one will make more sense just because we're doing another. All right, so again, they're giving us the distance. So this distance that we're going to set up equals square root 130. This one's already in a radical. So let's set up x minus x. So I think it's easier if we do 6 minus negative 3. You could do it the other way around, but I think it's easier to start there. Plus, and then y minus y, a minus negative 3. So 6 minus negative 3, that's really plus. That's going to be 9 squared, which is 81. And the second one, that's really a plus 3. So it's squared, meaning that we're doing it twice. So you got to either FOIL or use the box method on that. So I'll go ahead and use the box method again. Alright, a times a is a squared. A times 3 is 3a. 3 times a is 3a, and 3 times 3 is 9. Again, those are like terms. So what we have is we still have this 81 here, but then we have a squared plus 6a plus 9, and you can see that the 81 and the 9 are like terms. So I'm going to write it as a squared plus 6a plus 90. Now that is all still under the radical. So we're going to make a radical, and then that all still equals this radical up here, radical 130. Okay, so in order to get rid of the radical, actually both radicals incidentally, we need to square both sides. Okay, if you want to just put squared and squared, that's fine, I guess. I would know what you mean. So that's going to take off the radical. I mean, the thing is we have to rewrite it anyway for this step. You definitely have to do that. And it's also going to take off the radical from here. That just works out nicely, that when you square this square root, it just equals 130. Alright, just like the last one, we want to get everything on one side because you can see this is going to form a trinomial. So a squared plus 6a. What's 90 minus 130? It's helpful to have a calculator nearby when you do this. Negative 40. Okay? And then we'll go ahead and factor this. We want a, and then we're thinking, what two numbers multiply to make negative 40, but add to make 6? There's actually a few different combinations for how to make 40. I know one of them has to be negative and one has to be positive, so I'll just try some out. How about 2 and 20? So I'll do positive 2 and negative 20. Now those do multiply to make negative 40. What do they add to make? Let's see here, 2 and negative 20. That makes negative 18. So nope, that one's not going to work. Let's try another. What else multiplies to make 40? 8 and 5. 8 and 5. I'll do negative 8 and positive 5. You can see that negative 8 times positive 5 makes negative 40. What do you get when you add these, though? Negative 8 plus 5, that's negative 3. So that doesn't work either. What else multiplies to make 40? 4 and 10. I'll do plus 4 and minus 10. So those multiply to make negative 40. What do you get when you add 4 and negative 10? Does that work? That equals negative 6. Ooh, close. I don't want negative 6, I want positive 6. So what we'll need to do is switch the signs, minus 4 and plus 10. You can have those in either order as long as the 4 is negative, the 10 is positive. So let's go ahead and take that shortcut that we talked about. Since this is a minus 4, our answer is going to be 4. Since this is a plus 10, our answer is going to be negative 10. It actually ends up being the opposite. And we get two answers. There are two possible coordinates for a that it could have been in order for the distance to be radical 130. All right. So that first page is all about lesson 11.5 on the distance formula. Let's go on to the second page. All right. This page is all about similar triangles. So let's review what it means for two triangles to be similar, because that's what you have to do. Tell if the two triangles are similar or not. Explain how you know. All right. So two triangles are similar if one of them is just a bigger version of the other. This is the symbol for similar, this kind of wavy single line there. And so there are two things, concrete things that we know about similar triangles. All three pairs of corresponding angles, let's use that for angles, are equal. They're equal. So if these two are similar, let's say this is 80 degrees right here. If this is 80, that would mean this one would have to be 82. Even though this shape is bigger than this one, if they're similar, the angles will be the same. So let's say this angle right here is 45 degrees. If these two triangles are similar, then this also has to be 45. And what would the third set of angles be? Well, another thing we know about all triangles is that all triangles add up to 180. So if I wanted to figure it out, I could do 180 minus minus 45. And if you do that, you get 55 degrees. So that means the other set of angles are both 55 according to this. So that's one thing we know about similar triangles, is that all three pairs of corresponding angles are equal measure. All right, now we also know something else about similar triangles, and that is this. All three pairs of corresponding sides are not equal, but they form equal ratios. So, for instance, with these two triangles that we were talking about before, let's say this is a distance of 4 and this is a distance of 8. What's the ratio between those? Well, if we write them as a fraction, 4 over 8 equals 1/2. And what that means is every pair of sides that we compare that are corresponding, meaning they go together, they're in the same position, if these are similar, they all have to be that same relationship and they have to reduce to 1/2. So maybe this one is 5 and this one is 10. And if you reduce 5 over 10, you get 1/2. And I'm just making this up, but let's say this one right here is 7, then this one would have to be 14, because that's the only combination. If the first one's 7, that would make this reduce to 1/2. Alright, so both those things are true. Sometimes you only know things about the angles or only things about the sides, that's okay. But if they're similar, all three pairs of corresponding angles are equal. If they are similar, all three pairs of corresponding sides form equal ratios. The sides are not equal, though. Notice the sides are not equal, they're proportionate. They form equal ratios. Okay. So, let's take a look at these. Alright, number 7. Are the two triangles similar? Well, you can see we don't know anything about the sides, so this one's all about the angles. I don't know all the angles. We're going to have to figure them out. So like to find angle S here, I'm going to have to subtract from 180. We know that in any triangle, the three angles add up to 180. So one way that we can figure that out is to subtract from 180. 180 minus 75 and minus the 45. What's that equal? If I type that in my calculator, I get 60. So this angle right here is 60. Okay, so now I know all three of those angles. Let's figure out this angle, because I also don't know that one. Now, what some people like to do is they like to add together the two angles first, 50 plus 89. So if you add 50 plus 89, you get 139. And then they subtract that from 180. That's fine also. I feel like that's maybe a little more work, but if that way makes sense to you, that's fine. So that's 41 degrees. Okay, so if these two triangles are similar, then all three angles in this one should match all three angles in this one. Do we have any that are the same? Let's see here, 75 degrees? No. 60 degrees? No. In fact, none of them are the same. So we can officially say no. And I believe the directions ask you to explain. Yeah, explain how you know. No pairs of angles are equal. Your explanation could be as simple as that. In fact, even if only one or two pairs were equal, that still wouldn't be enough. It has to be all three pairs for them to be similar. Alright, let's take a look at number 8. Another one, kind of like it. Alright, let's figure out the missing angles. So I'll do the same thing that we did to figure these out. So to figure out G, I'm going to do 180 minus 90 minus 45. If you type that in, that actually equals 45 degrees. Okay, and let's figure out missing angle I. I'll do 180 minus 45 minus 45. And that actually equals 90 degrees. So I is 90 degrees. All right, let's compare. Angle E here, 45 degrees. That seems to match up with angle H, which is also 45. Okay. Look at angle F is 90. So is angle I. That's also 90. And look at angle G is 45. So is angle J. That's also 45. So do you see how these match up? We should say yes. All three pairs of angles are equal. They have equal measure. In geometry, we actually use the word congruent. But if you say equal, I think I know what you mean. Alright, now look at number 9 and 10. We don't know anything about the angles there. So we're going to have to use our other rule that we talked about, where if the two triangles are similar, their sides will form equal ratios. So we know all the sides. We just have to see how they match up. So for instance, this side 22, can you see what side on the other triangle that corresponds to? 33 is in a similar position. That's what we mean by corresponding sides, that they're in similar positions. So let's compare those. 22 over 33. Now you can either divide that out and get a decimal, which if I do that I get 0.6 repeating, or you could reduce the fraction, 22 fraction 33, and it equals 2/3. Either way, I'll just stick with the decimal. How about 0.6 repeating? Alright, now that doesn't tell us anything alone. What we need to do is figure out if all of the pairs of sides have that same relationship. So let's compare 29, and can you see which side 29 goes with in the other triangle? 43.5. So 29 divided by 43.5. Let's see what we get. Hey, I get 0.6 repeating, so it's looking good so far. Now there's no guarantee that just because the first two work, the third one will. So you really do have to check it. So the third one, I have 16 and 24. Hopefully you can see how those correspond. The question is, when I divide them, does that equal 2/3 or 0.6 repeating? And yes, it does. So, let's see, I need room to write an explanation. I'll just write it up here. Yes, all three pairs of sides form the ratio 0.6 repeating. Sometimes in geometry we call that the scale factor. That's how the two triangles are related through that number. Alright, let's do number 10. Okay, so same kind of thing. Let's compare 8 to 4. You can see that those match up. So 8 over 4, that just equals 2 when you divide it. How about 10 and 5? 10 over 5, that also equals 2. Alright, what about the last set of line segments? EF and BC? We don't know what they are. Now in geometry, we spend a whole unit on similar triangles and on when can you say they're similar or not. And we actually discuss more rules besides just these rules that we're discussing now. But the fact is, we don't have enough information. So are the two triangles similar? No, at least not that we know of. All three pairs of sides must form equal ratios. So kind of a trick question, I realize, but I want to make sure you understand the rules of similarity. All three pairs of sides must form equal ratios, and we don't know about the third side. About the third set. Okay, so hopefully that makes sense. You have a pretty good idea of what it means for two triangles to be similar. Now, in numbers 11 and 12, we're being told the triangles are similar. So we don't have to prove whether they are or not. This is telling us ABC is similar to DEF. All right. So find the value of any variable, show work, and here's basically what we're going to do. As the hint says, set up and solve a proportion. So number 11, can you find one pair of sides that correspond together where we know both? Well, this 20 and this 15, they go together, they correspond, and we know both. So we're going to set that up as a ratio. That's the ratio between them. You can reduce it if you want. You actually don't even have to reduce it. What we're going to do is set that equal to another pair. So like 10. What side does 10 go with? It goes with C, and we don't know what C is. So we're going to go in the same order. The way I've written this out, we're putting the first triangle on top, the second triangle on bottom. So when I do 10 and C, it would be 10 over c in that order. Now, just cross multiply. 20 times c equals 15 times 10, and 15 times 10 is 150. Divide by 20. So what is 150 divided by 20? It is 7.5. So c must equal 7.5. Oh yeah, I'd say that looks about right. Here's kind of another way to think about it. 10 is half of 20. So if these are similar, and they are similar, that means that this number has to be half of 15, which is 7.5. So, all right, let's find the last set. Notice how 16 and a go together. Well, I'm going to use my same setup group, 20 over 15, and then we're going to set that equal to 16 over a. So yeah, you kind of got to do two problems here. Now cross multiply. So on one side we'll have 20a. On the other side, what's 15 times 16? 240. And then we'll divide by 20. So you got to know how to set up the proportion, and then once you have it set up, hopefully you remember that you need to cross multiply. So that equals 12. All right, let's do another one. So these two triangles are similar. What's our control group? What's the set of numbers that we know go together? Well, 9 is going to correspond to 16.2. Can you see how those sides go together? So 9 over 16.2. That's going to be our setup. Now, let's pick another pair of sides in that same order. How about 4 and this side here? You can give that side a letter, or in geometry, we will often just call it by its pair of letter names. DE would be what we could call this. Even though there's two letters, it's just one number that represents. So now cross multiply. 9 times DE, 9 times DE equals, and then you got to do 16.2 times 4. I'm just going to type that into my calculator, and I get 64.8. And then divide both sides by 9, and it comes out to 7.2. So DE, the distance from D to E, is 7.2. Yeah, that seems reasonable. All right, now we still got to find the other missing side right here, BC. So let's use our same kind of control group, as I call it, 9 over 16.2. And we'll set that up as a proportion equal to BC over 10.8. This time the BC is going on top. The reason why is because it's in the first triangle, and the order I went in was just first triangle on top, second triangle on bottom. Alright, we got to cross multiply, so 9 times 10.8 is 97.2. And 16.2 times BC is just 16.2 BC. So to solve this, to get BC by itself, we need to divide by 16.2. And so BC equals 6, exactly. All right. And so we have found the missing sides. Okay, our last two pages and our last two lessons of this chapter were on sine, cosine, and tangent, which we call trigonometry functions or trigonometric functions. And what we learned is that sine, cosine, and tangent are ratios. It's where you compare two sides of a triangle, and you compare them based on a certain point of view from an angle. So On the front page of this packet, I have a little key that you'll get on the test. It's a good idea to memorize it, but it will be there if you need to fall back on it. And it basically just says if you take sine of an angle, that symbol right there just means theta, just an angle, it's going to be the opposite side divided by the hypotenuse side. The cosine of an angle is going to be the adjacent side over the hypotenuse side. And then the tangent one's a little bit different. The tangent of an angle is opposite side over adjacent side. So that one doesn't involve the hypotenuse. So let's review how that works with these number 13 questions here. So sine, cosine, tangent kind of combine angles and sides into one idea, but they are different. Angles are the measure of these points here and how big their opening is, relatively speaking, and sides are just a length, how long each side is. So they're related, but they're not the same thing. So when we say sine g, what that's saying is, look at this from G's point of view. Imagine you are right here and you're looking at the triangle from G's point of view. The three parts of this triangle are going to be opposite, adjacent, and hypotenuse. So you might find it helpful to label them. Now the hypotenuse is always the side across from the right angle. So in this case, the hypotenuse is 26. The other two sides, opposite and adjacent, depend on where you're looking from. So we are looking from point G at first, and so opposite is the side across from that. So this would be the opposite. Adjacent is the side right next to it. If you're thinking, well, isn't 26 adjacent to G also? Aren't they both adjacent? Yes, but that one already has a name, hypotenuse. So each one should be in a specific spot. All right, so now all we do is we follow the ratio of each of these and fill it in with the numbers. We're going to, as the directions say, do it as a simplified fraction and as a decimal, rounded correctly to 4 places. Okay, so sine is opposite over hypotenuse, so that's 24 over 26. And if you reduce that, you could type this into the calculator, 24 ABC 26. Actually, it just ends up dividing both the top and the bottom by 2. And so you get 12/13. That is our simplified fraction answer. And then what is 12 divided by 13? And we'll round that. You get approximately 0.9231 if you're rounding to 4 decimals. So we want both of those for this. All right, what about cosine of g? Well, cosine, as you can see, is adjacent over hypotenuse. So that's going to be 10 over 26. If you type that in and reduce it, you get 5/13. And if you actually divide 5 divided by 13, that rounds to 0.3846. And lastly for this part, tangent is opposite over adjacent, so that's 24 over 10. Remember, tangent is the one that does not involve the hypotenuse. And so if you type that into your calculator using the ABC button, it gives you 2 2/5. That's fine. You could answer like that. You could also say the answer is 12/5, which is what you would get if you just divided both top and bottom by 2. And so as a decimal, 2 2/5, just do the 2 divided by 5 part and it equals 0.4. So 2.4. No need to round there. We have a fraction and decimal answer. Now, look across to the right. We have a whole nother set of sine, cosine, tangent, but this time from H's point of view. So if you wrote in on this triangle, you may want to go back and erase because things are going to change. The hypotenuse is still 26. That doesn't change because that's always just the longest side, the side across the right angle. But if we're looking at this from h's point of view, now 24 is the adjacent side and 10 is the opposite side. See how it depends on your point of view? So sine of h, opposite over hypotenuse, 10 over 26. That reduces to 5/13. And if you divide 5 divided by 13, you get approximately 0.3846. Okay? The cosine of any angle is adjacent over hypotenuse. So for us, adjacent is 24, hypotenuse is 26. If you reduce that, you get 12/13. And if you divide 12 divided by 13 out, you get 0.9231. And lastly, tangent. Tangent is opposite over adjacent. So from our point of view, that would be 10 over 24. And if you reduce that, you get 5/12. And if you divide 5 divided by 12 and you round, you get 0.41. You could either put the 6 repeating, or if you're rounding, it would round to 7. I guess either one would be acceptable. So there you go. So that's just kind of a basic being able to identify what sine, cosine, and tangent are, and practicing that you know what ratio is what. So now we're going to go on to actually use these in order to solve. So in 14 through 18, solve to find the missing side length, show your work, round to the nearest tenth if necessary. So here's how we're going to look at these ones. Use the information that's given. 53 degrees is our angle that's given. 50 is the hypotenuse. And x is the adjacent side. So then you got to ask yourself, which function uses hypotenuse and adjacent? And if you look at your chart, or you have these memorized, it's cosine. Cosine of an angle equals adjacent over hypotenuse. See why it's helpful to have these memorized? So then what you can write is cosine 53, because we know the angle, equals adjacent over hypotenuse, x over 50. Now to get the x by itself, right now x is dividing by 50, so if you multiply both sides by 50, that will get rid of the 50. And now you're going to type this into your calculator. You'll probably have to use a parentheses because the calculator automatically puts one in, but you just type in 50 times cosine 53. And we'll round, because it usually does not come out evenly, and you should get 30.1. If we're rounding to one decimal place, it would be 30.1. Alright, let's do another, number 15. So again, use what you are given. We're given 45 degrees, y is the hypotenuse, 10 is the adjacent side. We're not using opposite. This would be opposite, but we're not even going to use it. So you can label it if you want to. I usually don't label the ones we're not going to use. So this is cosine again. Cosine of 45 equals adjacent over hypotenuse. Now, do you remember what to do when your variable's on the bottom? Multiplying by 10 is not going to work here. It's not going to even get rid of that 10, and it's going to keep this on the bottom. So officially what you do, and we have a shortcut, but I'll go ahead and explain why the shortcut works. Officially what you do is you actually multiply by the letter. So you multiply by y on both sides, and that will actually cancel the y, but it moves over here. So then you would have, if I rewrote it, y cosine 45 equals 10, but the y is not by itself. So to get the y by itself, you're going to divide by cosine 45, and so then look what you have remaining. You now have y equals 10 over cosine 45. So compare this, what we have here at the end, now y is by itself, to what we started with here. All that really happens is the cosine 45 and the y switch places. So that's usually what I do. I'm going to go ahead and erase most of this here, because usually I just take this shortcut and switch places. So if you just switch them places, you'll have y equals 10 over cosine 45. And so then you can just type that into your calculator and divide it. You type it in as 10 divided by cosine 45. Now you do that when the variable is on the bottom. That's when you have to do that. All right, this one equals 14.1. So y is approximately 14.1. All right, let's do another. Number 16. All right, now this is interesting. We're supposed to figure out w, but we don't know any of the angles. Well, we know this is 90 degrees, but we don't know the others. This is a case where your best bet would be to use the Pythagorean Theorem. A squared plus b squared equals c squared. Now remember which is which? C squared is the hypotenuse, so when you set this up, 33 has to be the one on the end. It doesn't matter between the 24 and the w, which one you call A, which one you call B. So here's how I would set it up. 24 squared plus w squared equals 33 squared. All right, what is 24 squared? 576. What is 33 squared? 1089. So we want to get the w by itself. You'll subtract 576. And that equals 513. And then we'll take the square root of both sides. So square root 513. Does that come out evenly? No, I get 22.6. And let's see if we can simplify 513. Let's see here. Does 513 divide by anything? Actually, it divides by 3 and 171. I wonder if 171 divides by anything. Oh, that divides by 3 and 57. I wonder if 57 divides by anything. 57 divides by 3. So what do you know? And you get 19, and I know 19 can't divide by anything else. So we have one pair of 3's. That's going to make it out. That's going to make it outside the radical. And then the 3 and the 19 multiply back together. Actually, I already know that's going to equal 57 because that's where they came from. So w equals these. And if you can give an exact answer, that's best. We round it also, because that's a good idea to do as well, but you should be able to give both. All right, let's keep going. Number 17. All right, let's use what we're given again. We have 28 degrees. This would be the hypotenuse, and we want to figure out j. From 28 degrees point of view, this would be the opposite. So you got to ask yourself, which function involves opposite and hypotenuse? So look at your chart or check your memory. Again, it's really helpful if you just memorize these. And it's sine. So sine of 28 equals opposite over hypotenuse, j over 20. All right, once you have this set up, this one's actually fairly straightforward. Since j is dividing by 20, you're going to multiply both sides by 20. And so you just type in 20 times sine of 28, and you get 9.4, approximately 9.4. Okay, number 18. What are we given here in number 18? Well, we're given 56 degrees. This side is the hypotenuse. I'm actually not even going to use that, but I'll just label it. T is the adjacent side, and 15 is the opposite. So I'm not going to use the hypotenuse, so which function uses opposite and adjacent? Tangent. So tangent 56, and its opposite over adjacent, equals 15 over t. Remember what to do if your variable's on the bottom? We can just switch places with the tangent. So it's going to say t equals 15. The 15 stays where it is, but now we're going to put tangent 56 on bottom. And so you just type that in. 15 divided by tangent 56. And t approximately equals 10.1. All right, on the last page here, numbers 19, 20, 21 say solve to find the missing angle. So these ones are different because we're looking for an angle. All right, so we want to find angle n, and we know these two sides, so 12 would be the adjacent side to n, and 7 is the opposite. So again, you got to ask yourself which function uses opposite and adjacent, and that's tangent. So we're going to say tangent of n equals 7 over 12. Now this is kind of an inverse situation, an opposite situation. You know what the tangent equals, but you don't know the angle. So this is the situation where we're going to say inverse tangent 7 over 12. It's like you're asking your calculator, what angle has a tangent equal to 7 over 12? And if you enter this in, you got to press second tangent. And you can just press, after that, 7 divided by 12. If you type that in and round, you get 30.3. So we're going to say angle n is approximately 30.3. In geometry, we put a little m here to say the measure of angle n equals 30.3 degrees. Okay, let's do another one like that, where we have to use the inverse function. All right, angle u is what we want this time. And so what are these two sides? Well, can you see that 31.3 is the hypotenuse because it's across from the right angle? And 7.5 would be the opposite. So which function uses hypotenuse and opposite? It is sine. So if we're looking at this from u's point of view, we can say sine u equals 7.5 over 31.3. And to actually figure out what u is, we're going to do inverse sine 7.5 divided by 31.3. And so you don't want to use the fraction button when you do this. I think you'll get an error. You want to press second sine and then 7.5 just divided by 31.3. I mean, if the fraction button doesn't give you an error, that's fine, but sometimes it does, and that would be why. So this means angle u is approximately 13.9 degrees. All right, last one of these. Find the measure of angle C. So here's C. Can you see that 26 is the hypotenuse, 14 is the adjacent? Which function uses adjacent and hypotenuse? It's cosine. So cosine of C equals adjacent over hypotenuse. But we want to know what is actually C. So we're going to do inverse cosine, 14 over 26. And you should get 57.4. So angle C equals about 57.4 degrees. Okay, now the last two problems, we're going to combine all of that sine, cosine, tangent stuff to solve the triangle. And as we talked about in class, solving the triangle means find all the missing sides and angles. We're going to show our work and we'll round if we have to. Alright, so let's look at 22. There are actually a bunch of different ways to figure out the missing pieces of information. But maybe the best thing to do to start with would be to just describe what is missing. If we want to know all three sides and all three angles, what's missing? Well, this angle, we don't know what that is. This side here, we don't know how long that is. And this side here, we don't know how long that is. Okay, you can figure these out in any order. It really doesn't matter the order you do it in, but it's like a three-part problem. So this problem will be a little bit longer because it's 3 in 1. I'm going to tackle this angle first. Let's use a rule that we talked about before that says in any triangle, all 3 angles have to add up to 180. So if I just do 180 minus 90, because that's what this angle's 90, and minus 50, it will tell me what's left over. And what's left over would be 40 degrees. So I'm just going to write that in. V is 40 degrees. Great. So now I know all the angles, 90, 50, 40. Now I still need to figure out this side and this side. So if you're looking for a missing side, usually what you would do is use a sine, cosine, or tangent. So pick an angle to view from. I'm going to view this from 50 degrees point of view. And let's find MD. From 50 degrees point of view, this would be the adjacent side, and this would be the opposite side. So which function uses adjacent and opposite? Tangent. So we could say tangent 50 equals opposite over adjacent, 21 over, you can either give this a letter name like X or Y or Z or something like that, or you could just call it by its 2 letters. In this case it would be MD. Remember what to do when your variable's on the bottom. You can make this little switch. So the distance from M to D is going to be 21 over tangent 50. Let's enter that in my calculator. 21 divided by tangent 50. And I get 17.6. So the distance from M to D is about 17.6. Okay, now we just need to find this third side here. Again, the way that I'm doing this is not the only way it can be done, it's just one of the ways. From here you actually have a couple options. Now that you know both of these sides, and you only have one missing side, you could use the Pythagorean Theorem. You could set this up as 21 squared plus 17.6 squared equals c squared, right? The last side squared. You could do that. I usually don't do that when I have a decimal just because it gets a little messy and because this 17.6 is a rounded number and so it's hard to deal with. But you could. You'd probably get it right and it would round out correctly. So here's what I'm going to do. I'm going to still look at this from 50 degrees point of view. I'm going to use 21, which is the opposite, and then this is the hypotenuse. And I'm just going to ignore this for now. So I'm just going to look at hypotenuse and opposite. Which function is hypotenuse and opposite? Sine. So sine 50 equals opposite over hypotenuse. 21 over, I'll call it VD for hypotenuse. And again, if your variable's on the bottom, you can just make this little switch. VD equals 21 over sine 50. And if you divide that, 21 divided by sine 50, you get 27.4. So VD is approximately 27.4. All right, now we have solved it. We know all 3 angles and all 3 sides. Let's do the very last problem, number 23. Okay, what are we missing here? Well, we're missing this side. We're missing angle U and angle E. Those are the 3 things that we need to find. Notice that we can't just subtract from 180 to figure out these angles like we could in the last one. That's because there's 2 angles missing. So what we'll have to do to figure out the angles here is use one of those inverse sine, cosine, or tangents. I'll show you what I mean. Let's say I want to figure out angle E. All right, from angle E's point of view, this would be the adjacent side. This is the hypotenuse. Which function is adjacent and hypotenuse? Cosine. So I could say the cosine of E is 15 over 18. But if you want to know what E actually is, you're going to do inverse cosine 15 over 18. And if you enter that in, inverse cosine 15 divided by 18, it equals 33.6 approximately. So angle E is approximately 33.6 degrees. Now that you know that's 33.6 degrees, if you want to figure out the last angle, you can now just subtract from 180. You know this angle right here is 90, so it'd say 180 minus 90 minus 33.6. And if you do that, you get 56.4 degrees. So this angle U is 56.4 degrees. All right, well now we know all the angles. We've figured them all out. We know two of the sides, we just need to know this last side. You have a choice for figuring out this last side. You could do like a sine or a cosine using one of the angles that you discovered, or you could also just use the Pythagorean Theorem. You know 15 is a leg, 18 is the hypotenuse, you're just looking for the other leg. So if UM is the side that we're missing, or you could call it X if you wanted. I'll go ahead and just call it X. So let's call this side X right here. I could say X squared plus 15 squared equals 18 squared. 15 squared is 225. 18 squared is 324. So if you subtract 225 from both sides, that equals 99, and then you take the square root 99. If you round that, that equals about 9.9. But I bet we can simplify it. What can you break down 99 into? 11 and 9. And 9 can be broken down into 3 and 3. So that would be 3 radical 11 would be our side there. Okay, well I hope this all made sense. Good luck in your studying.